Hello and welcome to another engine room tutorial. This video is an attempt to explain the concept of the RGB colour model by means of a simple visual analogy. RGB stands for red, green and blue, and it is the colour model used in projection and display systems such as computer and mobile device screens. It's also used in raster graphics software programs like Photoshop. Here we've got a simple representation of a projection screen and a lamp. In our analogy, the screen represents a single pixel, while the lamp represents an input that can change what the pixel is showing. I've moved the lamp away from the screen here, so that the screen is now filled with a light from the pixel. Depending on the type of lamp, the pixel can show different levels of brightness or different colours. However, an important point to grasp is the fact that a pixel is a fundamental unit. It can't be divided. This means it can't represent more than any one colour at any one time. So what can we do with this lamp? Well, we can turn it on and off. This means the pixel is either on or off, or we could say black or white. If we put a bunch of these black and white pixels together, they're probably going to look something like this. This is known as a 1-bit raster image. These are the type of graphics used in old fax machines and the first printers. In Photoshop, this graphics mode is known as the Bitmap Mode. It means that the pixel can only be in one of two states, black or white. This is a very limited type of pixel, but it only requires a very small amount of information to define it. 1 bit, in fact. Let's move on to grayscale graphics. Grayscale graphics mean that each pixel can represent any one value from a choice of 256 different shades of grey, including black and white. As you can see, a grayscale graphic looks much more realistic than a bitmap. Let's look at how this might be represented in our analogy. And here I've added a dial with 256 different positions on it. Each position represents a brightness level for the lamp. 0 is off and 255 is fully on. All the positions in between represent our shades of grey, and each one can be defined by a number between 0 and 255. So, all these shades of grey allow us to have a grayscale image. The quality is good, but the cost is in memory. Instead of each pixel requiring a 0 or a 1 to define it, it now requires a number between 0 and 255. In fact, a grayscale pixel uses 8 times more memory than a 1-bit pixel. Therefore, we can say that it uses 8 bits, which is also known as 1 byte. Right, let's have a look at how we can use our analogy to illustrate RGB colour. I'm going to drop a red filter in front of the lamp now to change the output to red. Now, instead of 256 brightness values of grey, I've got 250 brightness values of red. Let's see what happens if we add 2 more lamps to this scene, one with a green filter and one with a blue filter. We then have our red, green and blue system. Notice that where the colours overlap, they make a new brighter colour. Red, green and blue are light primary colours, and you can make any colour you want with these 3 colours by combining them in certain ways. And so on to the last step. All we need to complete this picture is the concept of 3 brightness controls, one for red, one for green and one for blue. Each control has 256 settings, so each can produce 256 different levels of its respective colour. Since they can be operated independently, then any colour can be created by combining these controls. So in summary then, we can say that with an RGB system on computers, it requires 3 sets of numbers, each ranging from 0 to 255 to store the colour of an RGB pixel. This means that an RGB pixel takes up 3 times the memory of a grayscale pixel. And the total number of colours an RGB system can present is determined by 256 times 256 times 256 equals about 16 million.